Okay, sorry about that. We had a couple of technical difficulties. So welcome to Meetup number 4, and so today we're going to basically first have a Q&A session with our FCC Judge Dale Jordan, and he's going to talk about this year's challenge, and you guys can just ask questions of any questions that you had after watching the video. And then we're going to have a show and tell of the design ideas that we asked you guys to bring. And if you don't have them, it's perfectly fine because we have some time for you guys to work on them if that's needed. And then we're going to vote on whose design you thought was the best, and then we'll have prizes at the end. Okay, so first we're going to start off with Dale Jordan talking about this year's challenge, and Alvinoy is not here right now, so we're just going to have Dale talk.
Just throw it at me. All right. Surprise, surprise. How many of you guys here, this is your first year for doing LTC? Okay, good. Are you guys feeling overwhelmed at this point? I don't see any heads going up. A little bit. That's the norm. It's good if you're feeling stretched, and like you maybe don't know exactly if you're going to get everything done. I can share some information last year that we had at ORTOP, and I think applies to the organization. You're not the only ones. Last year, quite often, and I think Kathy Sweeter, who runs this program, she made a statement, is that when we were putting on tournaments, it was like building the runway as the airplane was landing. And so if you're new to this is your first year, you're probably going to feel a lot the same way. That's okay. That's what this is all about. How many of you guys, I guess, what do you guys think of this year's challenge? Thumbs up? Yeah, I think it's an awesome challenge. I like the idea of the balls, the different sized balls. As teams have been coming around and they've been doing things over the years, they're used to one size object. And you kind of build your mechanisms to deal with that. And they've had some pretty sophisticated things over the past. But now you throw in multiple size balls, and they have to rethink the whole process. So that's one aspect I think is really exciting. You know, I think they've opened up the materials use this year, not only for mechanical, but also for those that want to explore sensors with some of the relaxation of the rules. They look to do that a little bit every year. And they're trying to do that in a controlled manner so that all of a sudden they don't get surprises, that teams discover things and they say, well, that's really not what we want this to be about. So you'll see each year as you go through this that they're going to get a little more lax. And so it's nice to see that. That can also be overwhelming as you're starting out. One of the things to remember is that basic kit of parts you get, you can use that to build about 99% of your robot, and if you want to, and you will be very competitive if you focus on those things. The teams that go way beyond that, they usually discover that to go beyond just the basics, it usually takes a lot of effort and energy. The things they learn from that is usually very positive, which is why they do it, but you get a small increased performance with a lot of increase in effort. So if you're coming in with just a kind of a standard Tetrix robot, you can expect to be quite competitive on the field. The game design committee, they design the games with that in mind, because they want anybody just coming in that can go ahead and be competitive. For the most part of other things, you guys want to do a Q&A at the end, or Q&A now?
We can do it now.
Okay, so I'll just open it up to you guys for any questions. We're early in the season and there's probably not a whole lot to talk about. So does anybody have any burning questions? Who wants to be first? How many of you guys, well, one of the things I will say is you're building your robot. There's the number one problem we see at tournaments with reliability on the field is the Tamiya connector on the battery and where it plugs into from your standard Tetrix stuff. We can't emphasize that's a reliability issue. We just can't emphasize that enough. And there are techniques to fix that, either cut it off and put other connectors on, or things you can do with the contacts to keep them reliable. It's been our number one issue for about 4 or 5 years now, and since the Tetrix came into being. And Teams, until they've had problems, their robot's been dead on the field a few times, sometimes don't appreciate what it takes to keep things alive. So we're trying to get the message out earlier this year that to pay attention to that connector and follow some procedures to keep it good contacts on there. There's good references there on the US First website under FTC, under Team Resources. There's a robot wiring guide, and I believe they talk quite a bit about keeping that up, and fixing that connector, or replacing it. Yeah, so number one problem we see. Last year at tournaments, the second highest problem was the program chooser. And when you're running under the field control system, your NXT has to keep track of which program is going to run a teleop, and then the field control system, when it's done with autonomous, switches over and runs that program automatically. What we believe has been happening is teams were going back to the pits between matches, and they're futzing around and making changes to things, and especially if they work in Robot C, somehow their program chooser, their program to run for teleop, gets switched over to their autonomous program. And as soon as the autonomous or the teleop starts, they're sitting there running the joysticks and their robot's doing something funky. And they're very frustrated over that. So it's number two problem we see. So always pay attention to that. This year, or last year, we piloted the program using anti-static spray to keep robots from locking up. That was highly successful in Oregon. This year, FIRST is going to recommend that for many other places. So there's some details that need to be worked out about that. Issue with that is it increases the friction on the mat between your wheels, the wheels and the mat. So if you're looking to push objects on the mat, that could be a problem, or if you have like a skid steer design, it might be a problem in turning. So we'll get that publicized as to what sprays we're using so you guys can practice in a similar environment. And that was the biggest issue we saw last year, is teams weren't prepared for the additional friction. So those are my hot items for this season. So if there are no questions, we'll turn it back over to you guys.
I have a question.
Yeah.
So that's a general question. So looking at the challenge and the rules, strict rules about not obstructing others and other things, what does it mean to be a defensive robot this year?
A differentiating robot?
No, defense.
Oh, defense.
Defensive robot.
Well, that's a good question. The game this year, again, looks like it was kind of, the rules are optimized for offensive type performance. Certainly from a defensive standpoint, you can go block paths all day long, just deny the other robot's positions. Certainly you can do some pushing around. So if your team does have a defensive robot, look really closely at what will cause a penalty to be called. Again, even in a highly offensive-minded game, defensive robots can have a real big impact on the results of the match. So, and they're also usually easier to design. You can design a little square bot that could just go block the path of anybody, and you can really frustrate your opponents. Again, that's one of the things when you're thinking about good offensive strategies and stuff like that. You need to keep in mind that there can be this little guy that's in there just getting in your way all the time. And what are you going to do to get around that? So it kind of works both ways. As the defensive strategies improve, your offensive strategies have to also improve.
Okay. So on the defense thing, the game manual says that you're not allowed to block path to the rolling goals. However, if you only block one path and you leave 3 other paths open, is that still illegal?
Oh, that's a good, I wish I were a head referee and I could answer that better. In the past, things like that were acceptable. You're allowed a position on the field, and if that happens to be the path that another robot wants to go, that doesn't put you in the wrong. But yeah, so I believe the same would hold true. Again, watch the Q&A, and then if we have some other sessions around going on, there'll be various sessions we have in Oregon here with the head referees talking about stuff. But yeah, those are always difficult things to call. What was the intent? And a lot of these go to intent. And to relay one story a couple of years ago, it was the last qualifying round, and these two teams were up there, they were paired against each other, and they realized that they weren't likely to be picked for the elimination rounds, and they were just having a bad day all around. And they says, well, let's just go see what we can do to accumulate the maximum penalty points, and see if we can bust up another robot. Well, they were talking about this strategy right in front of the referees. But normally the referees have a more difficult time calling stuff like that. And the end of all of that is they launched their robot off a platform and damaged a servo on another robot. And they were quietly escorted from the premises before the elimination round started. So, and the interesting thing that happens when those things go on is everybody acted appropriately. They just contacted the team, says this is the issue. And they were even allowed to stay, but the coach had had enough, and he pulled them out. They left early. Word spreads fast. And I tell you, we never had a single issue the rest of the year about destructive defensive strategies. So, but yeah, go ahead.
So there was one interpretation that you could pull the rolling goal behind you and score at the same time if you didn't actually grab the tube. And then somebody else said that probably wouldn't work. Do you have a thought on that?
Again, I could have lots of thoughts on that, but my thoughts don't mean anything. Post the question to the Q&A forum, or have your team do that. That's where the official answers are going to come from. Yeah, it sounded to me like you could probably do that, and I think that would be a really good strategy. I know a few years ago they had rolling goals like that. You could grab the centerpiece, and that was a really effective strategy. You just grab that goal and you drag it with you and you just keep feeding it. Yes?
How large is the base of the rolling goal?
Oh gosh, it's about this wide. It's got 5 sides.
Okay,
So it's a little bit-
That's about 6.5 inches.
Oh, it's probably about, I think more like about 10 inches maybe. Yeah.
In the rules, it says that if a robot knocks over one of the goals, it loses points for that. If your robot pushes another robot into a goal and the other robot knocks it over, whose fault would that be? Who would get the penalty?
The rules state that sort of the robot that actually knocked it over, if they were being pushed, would not get the penalty because, forgetting actually the wording on that, but yeah, it's, you have to have caused the action yourself. Now, would the team that pushed you get a penalty on that? That would be a good question for the referees. Again, that's a judgment thing because sometimes inadvertent things just happen because there's a lot of action going on, and I'm not sure what the calling would be on that. Yeah.
The rules say that once the balls all come out of the center loop, that they have to touch the ground before you can collect them. Would it be legal to pick up a piece of the mat and then hold it on like a tubing to make them fall onto the mat before you pick them up?
The short answer is no. Because if you picked up, separated the mats, that would be probably termed field destruction, and you'd get penalized for that. Good idea, good thinking though, I like that, yeah.
Along the same idea is that if you had just a tube that funneled the balls so they would hit the ground, but then be collected again, would that count as touching the ground and being collected?
That's all they have to do is just touch the mat, yeah.
Okay.
Doesn't matter how, they get to the mat, and I think probably the intent of that rule is they didn't want you to, although you can only possess 5 balls anyway, so I'm not sure why they needed to say that, but my thoughts are is they just don't want you to back up there with a dump truck, dump the balls, and move on. So, but yeah, I can't hardly think of a situation where the balls wouldn't hit the mat that you would not be penalized from something else. Maybe you guys have some thoughts of why that's an important rule. Somebody thought of something somewhere that they wanted to avoid, and that's why it's in there. Yes?
Can your robot split into 2 or more pieces?
Plug into, I don't understand.
Can
that
your
word.
robot split apart?
That becomes a very interesting issue. There have been cases in the past where robots have separated. The issue that would be addressed by the inspectors and the referees in that case is, does that present an entanglement hazard? So like if they're connected, you can only have one controller, so all of the intelligence and stuff is going to have to come from one, so you're going to need cabling and other stuff to the other. So does that present an entanglement hazard to other robots? And if that were deemed the case, then that would not be allowed. I have seen two different situations. One a few years ago where they kept an expanded thing up top that kept all the cabling and stuff together so that it was above a reasonable height, and that was ruled acceptable. But that robot didn't go very far. They were just doing this for fun. It was a clever idea. And the other one I did see was where they only deployed their secondary robot when they were next to a field wall and it was put up on a platform and just went a little ways to accomplish some objective. And that was ruled okay. So be careful on the entanglement hazards. Yes?
Are pneumatic parts allowed?
Are what?
Pneumatic parts?
I believe they are not allowed. Yeah, I know they were not allowed last year, and I think that is still true this year. I'm not sure why they disallowed them. That they used to be allowed a number of years ago, but they were only the Lego pneumatics. And to what, at least as far as pressures and stuff that could be built up by Lego pumps. I know teams were building their own pressure tank years ago and all this other cool stuff, and when there were lots of restrictions and things like that where they were having to straighten large PVC pipe for the ends. It was really some cool stuff teams were doing, but I believe at this point they're not allowed. I guess I'm ready to turn it back over to you, guys.
All right. Thank you. Okay, so next we're just gonna have some time to do a quick design for the challenge. Okay, so who came with a design already? Okay, so we're just gonna have about 30 minutes for everyone to get into your team, and then draw some designs and then we can present them or walk around and share them with each other, and then we'll vote after that. So we don't have Wi-Fi, so we can't play the video. So has anyone not seen the challenge video for this year? Okay, great. So we'll pass out some papers for some paper drawing designs.
I will make a comment on the ramps, the smooth ramps. If you guys haven't seen those yet, I had some emails from people wondering if that was an issue for trying to climb up with a robot. And it is a rather shallow angle, and so at home, since I have access to a lot of that material, I did run a test robot up and down it, and no problems with loss of friction or anything like that. And that was just with standard Tetris wheels and Omni wheels. It goes up slow, fast, the whole thing. So I don't think friction here is going to be an issue. Okay, so you're trying to get the first volunteer?
Yeah.
There's bonus points for the team to volunteer first.
Okay.
All right, nice.
Best videographer in the world.
So just real quick, we're the Osmanians. We're a rookie team, so if these ideas are bad, that is why. So one of our ideas is, since at the end you want to be up on the ramp or in your team's parking zone, we thought if you happen to need all your time to get up on the ramp or you know you're going to have a hard time getting up there, you could take 5 of the balls up there with you, and if you had a mechanism to shoot them,
Run with the
you
camera
shoot
there.
them in the goal that's worth a lot more
I'm right
points
there.
while you're there. If you need all the time to get up, and then any extra time you can spend trying to get a few more extra points. One of our other ideas we discussed right after the challenge came out was the tube you can hold by the base, and you can tilt it up to horizontal, but no further than that. So if we tilted it a little bit and held the base against the robot so it wouldn't move very much, we could have a ramp or a tube that would pull the balls with a spinning mechanism or something that would push them up into the tube and make it easier to score points. And then our last idea we drew was if you were going to try and collect a few of the balls directly from the basket as they're falling, they do need to touch the ground. So if you had a tube that was curved and had a slot opening at the bottom, so the balls could roll down, hit the floor, and then keep going up into other mechanisms, you could do do that, so they would count for points, and you wouldn't lose points because of that. So those are 3 ideas to go.
How would the balls, if they're on the floor, if the tube's curved, how would they get in there?
So we said this is for if you're trying to catch them like as they're falling. So the momentum, so if they're in the mechanism, you trigger it and they fall and they go down the tube like a roller coaster, so it has momentum to get back up and secure on the mechanisms.
All right, let's give him a hand.
Can you move this to the back over there because you can't see the here.
Oh, sorry.
Is this like tilted?
It's like those, the projector lines, and this has to be perpendicular.
So now we have our next team presenting, and you guys are for team 6590.
We haven't gotten a name established.
All right, that's fine.
Okay. So I guess I'll be speaking. I'm sorry if I messed up a lot because me and him both are kind of antisocial. So but that's just putting it good. That's just put it nicely. So our idea, we had the same sort of concept as the spinning idea because if you spin it, the ball will get picked up and shot into the tube. But then our tube is different because I'm not going to show the ideas because they're really, really complex. But so if they're shot up in the tube and there's something behind it, keeping them in, but the flat behind it, if you rotate it up with enough pressure, it will allow the balls in. So you can use this mechanism. So if you get to a goal on the rolling balls, you can lift the tube up, the flap will open, and the balls will roll into it. Versus actually just shooting into it, which is more complex, but also less accuracy with it. We also had an idea for the rolling goals, for the pulling. What we thought of is in the front, we thought of 2 bars that with hooks at the bottom of them, just 2 hooks like that, or 1 hook on each of them, and it can fold up and down. So technically, if you got close enough to the rolling goal, you could put it down and you could drag it along with only using the base, so it's not violating any rules because you're not allowed to pull it with the tube. Another thing that we thought of is making it multi-layered so it'd be easier to get the wiring done, and if it breaks during competition, you'll be able to rewire it back up very good. So the wiring is the first layer, the actual the foldable mechanism, so it stays in the 18 by 18 cube. That is layer 2. So for layer 2, that's where our kind of tube is. So if you guys want an idea of the tube, this is going to sound really weird, but the actual idea came from when I was sitting at home with my dad, and we had just bought Pringles since we don't typically eat Pringles. So we just ran out of them, and so my dad's like, this would since we were thinking about it, he said, this would actually do really well for picking up balls. So we messed with it a bit. He said, oh, well, how about we call this the Pringle can idea? So that's where the idea comes from, if anybody was curious. So it is foldable and it can expand. We're not expand, but go up and down. We're not sure how we're gonna get it to do that yet, since we did not come with pre-plans like everybody else. So this is kind of a quick sketch. So, yeah.
I didn't quite understand that, so could you elaborate?
Basically the flap is only on one end, the end that will pour the balls into the tube, the actual rolling bowl. The spinning thing is the one that's the side that picks it up.
Okay, so you've got this flap out there, so how do you know when to open the flap?
Because enough pressure from the balls will open it up.
Okay, so,
Yeah.
yeah, okay, gotcha.
There's a bit of physics involved, so.
And so it's just pressure, I mean, does the tube have to be there, like it won't open up unless the tube?
Yeah.
Okay.
Sort of like if you're, how many of you guys have ever been to Subway or at Disneyland or something like that? Can I get a show of hands to see if this thing will work? Or out the country? Those spinning things, when you go to the bus thing and they count people, you can go through them. They have 3 bars and they're connected to a machine and they count you as you go through. Now, if you walk through those, you can get in there just fine. But if you try walking back, they won't let you in. That's where that concept came from. Because I was surfing the internet, like an all-social person, But I just like saw a photo of that and I said, hey, that would do like really good for keeping the balls inside because you can't just like bump into it and like expect it to turn. You actually have to walk into it and for it to turn. Then you come back. The only way you're gonna get over it is to jump it. So, and balls can't jump. So that's for that. So.
See around, like the subway idea, or even the Pringles can, you can always take a look at mechanisms around the world and incorporate them into your own like robot. So who else hasn't gone? Raise your hands, guys. If you haven't gone, you have to raise your hands. You guys want to go ahead? Check it out. All right.
Yeah, she already said it.
So we're from Vernonia, and what we came up with is kind of like a conveyor belt, and you know, on the bottom of a vacuum, that spins and it collects dirt and little things to pick up off the floor. So when it comes to a ball, you can press a button and it'll spin, and the ball will come inside, kind of like a bucket, and the conveyor belt will scoop it up, and you can drop it into a cylinder, and to have it fit to an 18 by 18 cube. The conveyor belt can fold in half and kind of press down. Slider will be compacted. And we didn't draw this, but we didn't draw it. But for pushing the cylinders, you have kind of like a cup like thing, but with sides so that it's more stable. And that's already it.
All right, and I think we have one more team. You guys want to come here? Anyone? Come on, someone has to do it. You guys want to introduce what team you're from?
Okay, so we're from Team 8398, the Big Block Theory.
And this is our idea. So basically, it's a way to get the
rolling goals up the ramp, because even that has 30 points a rolling goal. So we felt that if you even just get yourself and all 3 rolling goals up the ramp, it's worth 120 points. But one concern, doing the hook mechanism to attach to the rolling goal is pretty simple. But one concern is because of the angle of the ramp. If your tube is filled with balls coming at such an angle at higher speeds,
the balls might fall out.
Might knock balls out. So we added another mechanism to that. It has it's like a double hinge almost. One hinge on top of the robot and the next on the other part of the arm, and it acts as a sort of cap onto the rolling goal where it can close it shut. So that way when you go up at the 25-degree angle, I believe, it doesn't balls don't fall out. And though this may add height, it can fall backwards because of the double axes and wrap around the robot. So in reality, it wouldn't actually add much to your robot's overall dimensions.
So it takes up less space.
Right. And so you basically, because of this amount of space on the ramp, you'll pull the goals up and then pull yourself up at the end. So, yeah. That's basically it.
But it can't really be considered transfer.
Yeah.
Okay, so is that 25 degrees or 50
Should I just ask really quick what big
Yeah. Well, the reason I was thinking 15 is
Well, I mean,
just
just
called out 15 degrees.
No, just ask them.
So it might even be better, which is a good thing.
Should I ask what their number was? Oh my god, can I just like shout it from here?
Yes. Big Bot Theory. What's your number? What's you guys' number?
8398.
Okay, thank you.
All right, so last one. Introduce yourself.
from earlier. And I just have a really short idea. It's just about having arms on the front of the robot that can just scrape in balls to the inside. And I don't know how they'd get up here, but you just use a water screw, and you spin them up, and then they fall into the cylinder. I don't know how to get up there or how it works, but
Have you given any thought as to how you would limit yourself to 5 balls at once?
yeah, I would think like you could start moving the times you could do it out like the spinner, you could accidentally get a bunch in there. But the arms would just jam in.
Okay, now we'll present an idea that we came with. Alright, so what we have is a ball sweeper. So what this looks like, or what we first envisioned it as, so this was an early sketch. We have some kind of zip ties or something like this that sweeps in balls into an attachment. So what is the ball sweeper? The ball sweeper is basically some kind of mechanism to collect balls into your robot. It uses zip ties or some other kind of materials such as surgical tubing to kind of grab onto the balls and sweep them into your robot, and it moves the balls from the floor into your scoring attachment. Alright, so how it works is these zip ties are connected to some kind of motor that rotates them, so it keeps rotating whenever you want more balls, and then it'll, so if whenever a ball comes in front of your robot, it'll sweep it in, and it'll push it in towards your attachment, so that then you can have it in a small container that you can then raise and dump into the goals. Alright, so now for pros and cons of this attachment. So some good things are it's easy to build. A lot of teams have used it in past challenges such as Block Party, or even in Gold Over, since they also have a lot of balls there. And it can also pick up lots of balls at one time, but that can also be a con since you might get more than 5 and you have to figure out ways to limit yourself and not somehow get rid of extra balls. And also it's not original, it's not unique. A lot of teams will probably do this, and a lot of teams have done it in the past. And also it's excellent.
Yeah, so basically just, sweep them. Well, I mean, you have a longer tube and the balls will be higher. But it's just like, get to the reach to your robot. Yeah. Any questions?
Does it matter what type of zip ties you use for this?
Just like surgical tubing or tie, something like long, and it won't like just bend, like break. It bends to a certain amount, so just like it bends to the ground and then drags it. Like it just drag it.
Thick cable ties might be better.
Yeah, cable ties.
Thick ones might be better.
Cable ties,
You can experiment with different materials and see what works for you best and what works best for this user.
In the past with the zip tie stuff, is teams will experiment with different sizes zip ties because they have different stiffness than the plastic, as well as the links. And certainly from a robot inspection standpoint, if you're starting to cut them off and they get very, very stiff and they're sweeping against the mat, they want to make sure that they're not going to damage the mat. But yeah, since day one, since FTC started, there was even teams in the past that were called the zip ties, because pretty much you look at a robot, it was just a collection of zip ties. It's such a useful device.
Yeah, so an idea is you can have it so it's a little shorter, so it only gets the big balls and not the small ones off the ground. So that could be an idea. So if you guys want to get the big ones first, so you dump those in the beginning to get more like a height, you can experiment with the side, the length of the zip ties or surgical tubing.
Does the pattern matter? The pattern, how you put the zip ties?
Yeah, it kind of does, I guess. We didn't really tighten it that much, but say if you have one up here and then like one here, you're gonna miss balls in between. We just experiment things, so I mean, well, I think personally if you have like one here, one on each like 90-degree angle, so it's like, because you want to, when you get on the floor, you want the zip ties to the floor like every half a second, so if you have more like spread apart, you'll always be dragging some balls.
Okay, so basically try out different designs, see what works best for you and work with that. So this requires a lot of experimentation since it has so many different options, and just find the one that works best for your scenario.
So how do you make sure that, that this ties don't turn around? Do you put glue or do you make
If you just tighten it, we tighten it the whole way so it's just moving around.